Hello, second grade scientists. Miss Hutchinson here in my backyard, ready for some science lab. We are experts at determining the physical properties of an object, and we have good practice in determining which materials, based on their properties, are the right materials to solve a problem. We're going to do that again today. We're going to test our knowledge of the properties of materials to solve another problem. Specifically, we're going to be looking at why shoes are made of the material they are, and what type of material is best for shoes that are meant to walk on a slippery surface. So I have an activity for us today called the Great Shoe Slide, and we're actually going to test different types of shoes or shoes versus plastic to see why it is that shoes are made out of the materials they are. Do you have any thoughts? Why are shoes made out of the certain materials that they are made of? Those are some interesting points. All right, we're going to take a look at our materials to see what you need in order to try the Great Shoe Slide at home. As I mentioned, there are two options for trying this activity at home: testing different types of shoes or comparing your shoe to plastic. If you're going to test different shoes, I recommend you choose 3 different types of shoes, like a sneaker, sandal, and flat. Or choose one of your shoes and also have a plastic bag on hand. For both options, you will need tape, measuring tape or ruler, hopefully with centimeters, and if you'd like to record using the datasheet, the correct datasheet for which option you choose, and a pencil. You can always go paper-free if that works better for you. I plan on testing different types of shoes to see which one would be best for walking on a slippery surface. So I have my materials: a sneaker, a flat, and a sandal. Now, either option you choose, you're also going to need like some masking tape. So I have my tape and a tape measure or a ruler. That way you can measure how far your shoe actually slides. So I'm going to go over the procedures for both activities. You can pause the video when it's time for the activity you're going to try, either the 3 different types of shoes or a shoe versus a plastic bag, and pause the video so you can try the activity at home. If you don't have materials to try at all, after the procedures, I'm also going to do the demonstration trying the 3 different types of shoes. Now, before you try any sliding at home, if you're using the data sheet I mentioned in the materials, there's a spot for a hypothesis. So pause, make a hypothesis, and then you can use the procedures to try out the experiment at home. If you plan on testing different types of shoes, here is the procedure to follow. 1. Find a smooth surface or a surface with little friction. 2. Create a starting line with your tape. Get your first shoe, maybe a sneaker. 3. Set it right side up and slide it right side up. Do not throw it. 4. Measure the distance your shoe traveled as soon as it stops, from the starting line to the heel of the shoe. 5. Record the distance on your data sheet in the table under Experiment. 6. Go back to your starting line and repeat steps 3 through 5 2 more times with your sneaker. 7. Choose your next shoe, maybe the flat. Complete steps 3 through 5, sliding the shoe right side up, measuring how far it slid, and recording in the table under Experiment 3 times. 8. Choose your final shoe. That leaves the sandal. Complete steps 3 through 5, sliding the shoe right side up, measuring how far it slid, and recording in the table under Experiment 3 times. If this is the procedure you are planning to use, pause the video now and try out the activity. Come back and see our reflection questions. If you plan on testing your shoe versus plastic, here is the procedure to follow. 1. Find a smooth surface or a surface with little friction. 2. Create a starting line with your tape. Get your shoe. 3. Set it right side up and slide it right side up. Do not throw it. 4. Measure the distance your shoe traveled as soon as it stops, from the starting line to the heel of the shoe. 5. Record the distance on your datasheet in the table under Experiment. 6. Now go back to your starting line and repeat steps 3 through 5 2 more times with your shoe. 7. Now put your shoe in a plastic bag, Ziploc, grocery, vegetable, whatever you have. Go to your starting line and slide your shoe while in the bag right side up. 8. Measure the distance your shoe in the plastic bag traveled as soon as it stops, from the starting line to the heel of the shoe. 9. Record the distance on your datasheet in the table under Experiment. 10. Go back to your starting line and repeat steps 7 through 9 2 more times with your shoe in the plastic bag. If this is the procedure you plan to follow, pause the video now and give the activity a try. Then come back and you can join us for the reflection questions. Now that we've gone over the steps, it's time to actually carry out the procedure. So, if you haven't already done your experiment and you need to make a prediction, do that now. I'll do mine on my own worksheet. And then for this experiment, I'm actually going to head inside because I don't have a smooth surface outside to use. So I'm going to head into the house. All right, let's go. All right, I've moved inside and I'm ready to try out the Great Shoe Slide. I already set up my starting line. I have my materials on the other end of my hallway. I'm going to go stand over there and we're going to get started. Here I am at my starting line. I'm going to start off with my sneaker. And remember, I'm not going to throw it. I'm going to slide it and I'm going to try to release before it crosses my starting line. We're going to do it 3 times and I'm going to record on my sheet of paper over here. Ready? 1, 2, 3. All right, I've got my measuring tape from the starting line to my shoe. I'd say that is 62, 4, 6, 68 centimeters. Okay, I'm going to write it down. Here I go again. Ready? 1, 2, 3. Ooh, that one didn't go quite as far. Okay, here we go. Let's see. Ooh, I only went about 33 centimeters that time. Let's record it. And one more time with my sneaker. Ready? 1, 2, 3. Ooh, a bit farther that time. Let's see. For my starting line, 60, 90. Ooh, I'm going to say I went 97 centimeters. Wow, so much farther this time. All right. Now it's time for my flat. Ready? I've got my flat, and we're going to measure how far that goes. 1, 2, 3. Whoa, that was really long. Let's see how far we get. Okay. My starting line. Ooh, 200, 230. 260, 264 centimeters. I'm going to grab my shoe and record it down. Go. Woo, 264 centimeters. All right, test number 2, here we go. 1, 2, 3. Ooh, nice and straight for that one. All right, let's see. Got 130, 60, let's see, that's 200, 230, 242 centimeters. Wow, another long one. Let's go record it and try one more time. 242. Okie dokie, last try with my flat. 1, 2, 3. Okie doke, here we go. 100. Ooh, not quite 200 centimeters this time. 130, 160, 182 centimeters. 182 centimeters. All right, that's 3 trials. 182. My flat's done. My sneaker is done. Just have the sandal left. 3 trials. 1, 2, 3. Ooh, not bad. Let's see how far that went. Here we start to about there. Ooh, we've got 127 centimeters. Okay. 127. 2 more trials. 1, 2, 3. Okay, here we go again. 100, 130, 135 centimeters. Ooh, it went a little farther. Okay. Got it written down, and we're on to our very last trial. Ready? 1, 2, 3. Whoa, that one went far and it spun. So I'm going to measure to the toe instead of the heel. We've got 100 centimeters, 200 centimeters, ooh, 200, let's see, 215 centimeters. Not bad, not bad. Okay, I'm gonna write it down. All right. Now that we have all of our trials done, let's take a look at our results, and then we can decide which shoe is best for walking on a slippery surface. Here's a copy of my data sheet for the different types of shoes. First, I answered the question, are sneakers, flats, or sandals best at keeping someone from sliding on a smooth floor? My hypothesis was that sneakers are the best because they have a thick sole and there is a pattern on the bottom that I think will help. Then as I went, I copied my data on another piece of paper and I put it here in the table. Check your data too. Do you have all of your data filled out? Here's what I had at the end of my experiment. Now that we've looked at our data, let's talk about our results. First up, circle the distance that went the farthest for each shoe, or for both the shoe alone and the shoe in the plastic bag. After you've done that, answer this question. Which shoe traveled the furthest? What material do you think the bottom is made of? Or which type of material made your shoe travel the furthest? The bottom of the shoe or the plastic bag? I couldn't figure out how to circle on my data sheet, so I highlighted the furthest distance for each shoe in the chart. Then I decided which shoe traveled the furthest. Based on my highlights, that was the flat. I looked at the bottom of my flat shoe to check out the material of the sole. It's definitely made of rubber, but then it's covered in fabric, which is a pretty slippery material. To answer my original question, I want to find the shoe that is best for walking on a slippery surface. That would mean looking for the shoe that traveled the least distance. And in this case, it's my sneaker, so it looks like my hypothesis was correct. But why is the sneaker the best shoe for walking on a slippery surface? All right, I've moved back outside for our reflection and conclusion. So today, as we did our great shoe slide, we were actually looking at a certain force. It's called friction. And friction is a force between our shoe and the floor that actually causes objects to either speed up or slow down. Now that you know about this force called friction, how could it be useful? Why don't you turn and tell someone how you think friction might be useful when we are looking at shoe material? Those are some excellent thoughts. If we need to walk on a slippery surface, we want to make sure we have a material in our shoe that has a lot of friction in comparison to the floor. That way we don't go slipping and sliding. So why do some shoes have more friction than others? When we tested our different shoes, you noticed that some shoes slid further than others, and that has to do with how much friction they have. If you tested a plastic bag, you should have seen a difference between your shoe and the plastic bag. Again, why does that happen? Why is there different friction? What do you think? Yeah, we're looking at different materials, and different materials will have a different amount of friction between a surface. So we had a nice smooth surface, but different materials to test. And we saw that when we tested our different shoes or our shoe versus a plastic bag. So as a final thought, talk about what material you think would be the best type of material for shoes that are meant for playing on the playground. And why do you think that? I'm going to leave you with that thought. And until I see you again, little scientists, stay curious.